Okay, let's dive right into this explainer. Today we're looking at a massive shift happening right now in tech, how we transition from building these isolated single AI models to actually governing massive, interconnected, intelligent systems that take real actions in the real world. For years, the entire AI industry had basically one goal, right? Just make the model smarter and more capable. But we are rapidly moving way past the era of the isolated chatbot. Today's AI systems are these sprawling ecosystems. We're talking language models, retrieval systems, autonomous agents, external APIs, and human users all interacting at once. And when you connect all these highly capable pieces, raw intelligence stops being our only bottleneck. Suddenly, coordination, trust, observability, and authority, those become our biggest headaches. So today we're going to explore a really fascinating convergence of ideas. We're looking at how mindfulness frameworks and decades of US military research are actually coming together to give us the exact blueprint we need to solve this next huge hurdle in AI architecture: cognitive control.
So this right here is the consequential new engineering question we're facing. We have to shift our focus from simple cognition to the absolute critical need for machine metacognition. It used to be we just asked, hey, can this AI model produce a smart answer? But an agentic AI is a whole different beast than a search engine. It interprets ambiguous instructions, it generates complex plans, it invokes tools, it even rewrites its own intermediate steps. So the new question we have to ask is, can the system understand where its knowledge actually came from? Can it gauge how reliable its own components are? Think about it. Human beings don't just think. We think about our thinking. We notice when we're uncertain. We recognize when facts conflict, and we question where our own beliefs originated. Individual AI models might show little fragments of this, sure, but current systems generally lack a persistent, independent layer that oversees all the agents and memories. For us as engineers, the new imperative is building operational metacognition into the machine.
And this concept perfectly illustrates exactly why we need that metacognitive layer. The core problem with modern AI is how it dangerously compresses observation, interpretation, and action into a single instantaneous and completely untraceable step. It creates a black box that engineers simply cannot safely govern. Think about how a standard large language model works today. It takes in evidence, interprets it, estimates an answer, assigns confidence, and generates fluent text pretty much all at the exact same time. To a user, it just looks like one single, highly confident statement. The boundaries between observing the data and interpreting the data completely vanish. And if that assertion automatically triggers an agent to take an action, like say sending an email or dropping a database table, well, that dangerous compression goes straight from observation to action. You get a black box where all the reasoning is totally hidden. The safer approach, which you see on the right, demands separation before commitment. Every single step must be distinct.
Which brings us to Section 1, Mindfulness and Epistemic Separation, the unexpected origin of AI control. To solve this whole engineering crisis, we actually find a really unexpected blueprint in a seemingly totally unrelated field: mindfulness teacher Michelle McDonald's study of human experience.
Long before autonomous software agents were even a thing, Michelle McDonald developed this incredibly compact framework for examining human experience. It's called the RAIN framework, and it's brilliant because it intentionally inserts a crucial separation between stages. It actively prevents an immediate automatic reaction from replacing pure observation. First, you have recognize, just asking what is actually happening right now. Then, allow, pausing so an immediate reaction doesn't hijack the observation. Next is investigate, asking about the nature of what was just observed. And finally, non-identification, introducing the really crucial distinction that the experience or interpretation is not identical to the observer. Now, to be clear, McDonald was obviously describing human cognition here, not computing. But the conceptual correspondence for AI architects is just incredibly useful. RAIN formalizes the discipline of observing cognition without automatically identifying with its content. It's literally all about avoiding that unchecked automatic reaction.
So for AI architects, this translates directly into what we call epistemic separation. This is the absolute non-negotiable necessity that an intelligent system distinguishes what it actually observed from its inferences and its permitted actions. This is a foundational concept. Look, an observation is not an inference. An inference is not confidence, and confidence is absolutely not authority. If an AI reads a sensor and infers a conclusion from it, those are two distinct states, and they should never, ever be collapsed into one generated sentence. The system has to maintain a structured awareness of what it saw versus what it guessed. It needs to track what evidence supports an inference, what contradicts it, and what the system is actually permitted to do about it. By enforcing this epistemic separation, we essentially turn the AI from a black box that just blurts out confident answers into a transparent system where every single transformation of data is perfectly visible.
Moving on to Section 2, Calibrated Trust in Military Teams. From permanent labels to dynamic states. Let's look at our second converging path here and see how this builds on decades of U.S. Army research into human autonomy teaming. This gives us our next big piece of the puzzle.
So the military realized a while ago that just labeling a system as permanently trustworthy causes really dangerous overtrust or undertrust. Trust has to be a dynamic, continuously inferred state based on actual capability in that specific moment. The Army has spent years studying human autonomy teaming, soldiers working alongside complex machines in highly unpredictable environments. And what they quickly learned is that asking if an AI is universally trustworthy is completely the wrong abstraction. Think about it. A component might be highly reliable at extracting text from a document, but absolutely terrible at long-horizon prediction. If you just slap a trustworthy label on the whole model, you destroy incredibly useful information. If a human overtrusts the machine, confidence exceeds actual capability. If they undertrust it, confidence falls below capability, which degrades the whole team's performance. Instead, military research demands calibrated trust. We need to be asking, how much trust is warranted for this specific system, performing this specific task under these exact conditions, right this second?
Because trust is a relational graph rather than just a simple binary switch, a control system has to infer reliability from multiple independent signals rather than just taking the model's word for it. The Army's Trust Toolkit, known as HAT3, proved that no single measurement can adequately capture the state of a human autonomy team. Trust is a latent state. You can't just stick a thermometer in it and measure it directly. You have to infer it from various signals. And this matters so much for AI architecture. Right now, it's pretty common practice to just let an AI model state its own confidence, like generating the text, "I am 94% confident." But confidence is not truth. That is literally just the model grading its own homework. A proper control system needs to look at the quality of the retrieved evidence, source agreement, data freshness, and whether there's contradictory evidence floating around. Trust has to dynamically update based on all these heterogeneous signals in real time.
And that takes us to Section 3, the WARDEN control plane, a metacognitive layer for artificial intelligence. The really crucial point here is that these concepts of mindfulness and military calibration converge directly into WARDEN, which is a cognitive control plane for modern AI architectures. Let's break down how this actually operates in practice. WARDEN externalizes all those functions that are usually buried deep inside model behavior by systematically separating every stage of cognition. It starts with raw observation and meticulously preserves data lineage before any inferences are even compared. Try to think of WARDEN not as just another AI model competing with your other models, but as a control plane. Very much like in networking, where your data plane actually moves the packets, but your control plane determines how the whole system should operate. This first half of the pipeline is entirely about that epistemic separation we talked about. First, it observes a raw event. Then, crucially, it preserves the provenance. Where did this come from? Which agent processed it? What's the exact data lineage? Third, it attributes those components correctly. Fourth, it investigates the dependencies and context. And fifth, it compares supporting versus contradictory evidence. Instead of letting an LLM just instantaneously blurt out an answer, WARDEN forces the system to pause, separate the observation from the interpretation, and maintain highly structured knowledge about its own internal state.
From there, the pipeline moves through calibration and authorization. This guarantees that machine reasoning doesn't just silently become machine action, without a totally observable, audited path between the two. This is where the military's calibrated trust comes in. First, WARDEN calibrates trust dynamically by comparing the expected capability with the observed performance. But this next step is the absolute most critical one: authorize. WARDEN explicitly stops and asks what the relevant model or agent is actually permitted to do. It decides whether to allow, verify, constrain, or totally deny an action before the action ever happens. Step 3 is the actual act of executing. And finally, Step 4 is to audit what changed and whether the expected result actually occurred. For developers, this formalizes a computational architecture where an AI-generated representation of reality is not automatically treated as authorized reality. Separation before commitment.
Let's look at an example. Take this standard contextless AI output. It looks entirely confident and simple, right? But that simplicity could easily trigger a completely unjustified automated response. If an autonomous system reports this simple sentence to a user or feeds it directly into another software tool, it looks like a hard, irrefutable fact. Without provenance, without knowing how the AI arrived at this specific number, a downstream system might automatically adjust a building's HVAC systems or trigger some security protocol based on a supposedly full building. It's a perfect example of that dangerous compression. The model observed something, interpreted it, and made a firm assertion all in one breath. But what is actually hiding behind that 92%?
Well, when WARDEN attaches provenance to it, we instantly see a totally different story. Suddenly, 92% doesn't mean what we thought it meant. Yes, the model confidence is high, 0.92, but WARDEN exposes that the source reliability is only 0.71. And look at this. There are actually two contradictory sources that the model just completely glossed over. But most importantly, we see the agent's authority is strictly set to recommendation only. Its permitted action isn't to go adjust the building's critical systems. It is forced to escalate this for human verification. You absolutely cannot recover this vital context from the number 92% alone. And this is exactly why provenance and state estimation belong inside the live control architecture rather than in some static audit report that gets generated weeks after something goes horribly wrong.
And this introduces the concept of operational explainability. This goes way, way beyond just asking why a single model produced a specific word. It demands to know what happened across all the agents, tools, and memories. A lot of the current discourse around AI safety focuses really strictly on traditional explainable AI, mapping out the weights and pathways to figure out why a specific language model chose one token over another token. And while that kind of explainability definitely matters, when you are governing an entire ecosystem of autonomous tools, it is simply no longer enough. A governed intelligence system has to pivot to being operationally legible. You need to be able to answer instantly which agent processed this data, what evidence was missing, which tools were invoked, which policies applied, and what authority did that agent actually possess when it requested an action. Making the behavior, state, and boundaries of the entire system legible, that is the core mission of WARDEN.
Section 4. Intelligence is not authority, establishing boundaries in AI architecture. This brings us to what is arguably the most vital takeaway for anyone building heterogeneous AI collectives. We have to separate what a system is smart enough to do from what it is actually allowed to do.
Just like mature databases and networks, AI infrastructure has to draw a hard, unambiguous boundary between an agent's capability to generate a strategy and its actual authority to execute it. Listen, capability does not imply authority. An AI planning model might analyze a massive amount of data and produce an absolutely brilliant, totally flawless strategy. It correctly infers exactly what should happen. That is amazing capability. But that does not mean every downstream system should just blindly execute that strategy automatically. We don't build our standard IT infrastructure this way, right? Operating systems don't just give every single process unrestricted access to all hardware resources. Databases don't let every authenticated user modify every single record. AI infrastructure has to undergo this exact same maturation process. Intelligence without authority boundaries isn't an architecture. It is an uncontrolled, highly dangerous capability surface. We have to explicitly ask, is this component authorized to do this before any action is ever permitted?
As we scale up into a future governed by massive AI collectives and autonomous tools, we have to stop treating capability as our only bottleneck and answer this ultimate question. The future of artificial intelligence isn't going to be some single, omniscient brain sitting alone in a void. It's going to be characterized by more models, more agents, more tools, and vastly more autonomy all interacting simultaneously. The era of the black box is ending, because when intelligence swarms begin governing themselves, observability and calibrated trust are literally the only things keeping them from causing absolute chaos. We've seen how mindfulness teaches us the power of separating pure observation from automatic reaction. And we've seen how military research proves that trust has to be dynamically earned, not just blindly given. By fusing these concepts into a cognitive control plane like WARDEN, we can finally ensure that machine reasoning never silently becomes machine action. But ultimately, it all comes back to this one provocation. As these systems become unimaginably capable, who or what is watching the intelligence itself? That is the architectural challenge of our time.